Hello everybody. This is the lesson for Wednesday, the 20th. And today's lesson is a video lesson called The Day the Earth Shook. I need you to write these notes down as we go. They're important. The Day the Earth Shook. Okay, this is a NOVA video about two important earthquakes. It's going to compare NOVA video that compares two important earthquakes. Because there's something valuable to learn when we look at these two, okay? So what I want you to write down is 1/17/1994. This might have been when your parents were one of my students, okay? 1994. And then do this. And then 1/17/1995. One earthquake happens on January 17th, 1994, and then exactly a year later, another one hits, but they're completely different in the number of people that they killed, okay? They happened at the same time of the day and everything. All right, this first one is in Northridge, California. Everybody just calls it the Northridge earthquake. It's a famous earthquake, okay? Tell yourself it's a suburb of Los Angeles. This one is in a major city in Japan called Kobe. Looks like Kobe Bryant, okay? But this is Kobe is the name of the city. Kobe, Japan. Okay. Remember, you can always get a hold of me. Here's the email. And later on in this video, there are some scenes that are kind of disturbing. Okay, a little bit. Here we go.
On January 17, 1995, Japan had its worst catastrophe since World War II. The city of Kobe was ripped apart by an earthquake of magnitude 6.9. More than 5,000 people died. One year before, to the day, Los Angeles nearly suffered the same fate. Good morning. The time is 4:30 on Monday.
4:30 in the morning.
The suburb of Northridge was hit by a quake of magnitude 6.7.
Birds being shaken out of the palm trees. Somebody's pool going nuts.
100 people were seriously injured and 57 people died. But the city of Los Angeles itself had a narrow escape.
What I can say is we just experienced a real whopper here.
Look, broken water lines. You're not going to be able to put out the fires. There goes a motorcycle being washed away. There's a broken gas line.
Two earthquakes, same date, same magnitude, but casualty figures.
He's going to run out of water.
Different. Why? Comparing the two earthquakes, scientists have reached conclusions that are both alarming and hopeful.
Look how dark it is. They don't have any power. No electricity.
But it need not cause massive loss of life. Many scientists believe that it should be possible for no one to die in an earthquake, but only if the lessons of these two earthquakes are learned, only if the stories they tell are heard. A young teacher who lived through the Northridge experience, Makiko Yoshihara, later returned to Japan.
Preschool teacher. She lived through both earthquakes. She's the only person we know of that did that.
She continues to teach nursery school children near her home in Kobe, 500 miles southwest of Tokyo. In the early morning of January 17, 1995, 15 miles below the surface, and almost directly under the city of Kobe, the earth was preparing to shake again.
All right. Real quick, write this down. Then you're going to be done writing for quite a while. Okay? All right. Kobe was a 6.9 on the Richter scale. Northridge was a 6.7. Those are pretty similar. Okay? 57 people were killed in LA. But in Kobe, it was over 5,700. The question is, why? They're both big cities, in a way, okay? LA is a big city. The scale is the same, the time of the day is the same, time of the year is the same, but look at the death toll. Okay, get ready to watch. This is very important. You're going to see this next. You'll see the same video clip repeated several times. Okay, I call him Mr. Futon. Okay. Watch the guy sleeping. Let's put the video back on. He's sleeping on a futon. He's at the bottom of the screen. He's got the early morning shift at this Japanese news station. It's like the Japanese version of CNN, a 24-hour news station. Okay, I'm gonna hit play. Watch him wake up when the earthquake hits.
In the office of a television station, a security camera was watching.
He's at the very bottom of the screen, down by the number 5. He's right there. He's on a futon. He just curled up. He's covering his head so something doesn't fall on him.
Firstly, I was lying in bed and felt violent movements up and down and then sideways. I was very frightened. My sister was about to go to work and she was up. She yelled at me, "Big sister, get a flashlight." The crashing went on.
They had no power.
For a long time. I was very scared. My bookshelf fell down. I could hear the cupboard rattling and dishes cracking inside. I watched the TV come crashing down, and the VCR, and even the piano was moving around in its place. As to Kobe and Northridge, it seems really strange to have been in 2 such big quakes in my lifetime.
Outside Kobe, the first anybody knew about it was from the television network NHK.
This is that same network that Mr. Futon worked for.
Along with the weather information, the morning show from Tokyo carried reports of an earthquake being felt all over Japan. Seismometers in central Japan were showing ground shaking at magnitude 4, but the seismometers in Kobe were silent.
I wonder why Kobe isn't giving them a report.
Nobody outside
Because they got nailed. Look at what's happening in Kobe.
were already on fire.
Look at the fires.
Ignited by sparks from fallen power cables, broken gas mains blazed. Toppled oil stoves, recently lit for breakfast, added to the fires.
It's wintertime. People had a lot of heaters going.
20 minutes after the event, Tokyo got through by phone to reporter Norio Saki in the Kobe newsroom.
Okay, he's talking to Mr. Futon.
He had been asleep, waiting for his shift to start.
Okay, here we are again. Watch. He just felt it. See his head stick up? There, he just covered
It
up.
occurred to me that it might be an earthquake.
That's Mr. Futon.
Then the violent shaking started. in all directions. I curled up inside my
That thing just about hit him.
The lights went up because of the violence of the shaking. I was so scared. What I remember most is that I was so scared of the darkness.
20 seconds later in Osaka, 30 miles from
Notice
Kobe,
things aren't shaking as much. See the sign moving?
shaken from their desks, but to a much lesser extent.
They were farther from the earthquake, so they aren't shaking as much.
It was a full half hour later that Japan's central seismic computer plotted the epicenter just southwest of Kobe.
震度5を記録しています。また震度4がかなり広い範囲。
Look at Kobe.
By now, entire sections of the city were in flames. Small fires became conflagrations.
Now look, the dark areas are the streets. The whole block is burning.
Hundreds of people died.
Those black areas are streets. Everything else is on fire.
Survivors were unable to do anything but watch in stunned silence. The lack of seismic information had meant that fire and rescue services were not immediately alerted. Then, compounding the tragedy, only a few roads were open.
Look at the traffic jam.
Earthquake damage.
Fire trucks can't get through, and they're running out of water.
When they got through, the firemen faced a classic dilemma: to help people trapped in burning buildings, or to get the main fires under control. They were well equipped, but not for a battle on so many fronts.
There are too many fires. And not enough water and not enough firemen. They're just about out of water.
They soon began to run out of water. The fires had been so large and unexpected. The emergency tanks underground were just not big enough to cope with such a demand.
That was a water tank. They sucked it dry.
Dawn began to reveal the full extent of the horror. The destruction made a previously peaceful city seem like a war zone.
You can tell there's wind. That does not
One
help.
of the worst hit areas was the district of Nagata. This was the market arcade, surrounded by houses. Many died in their homes right here.
There's a burned out Coke machine.
Kobe's shoe factories with stockpiles of rubber and chemicals had provided extra fuel for the fires.
Look at it.
An entire community had been burnt to the ground. Over 1,000 people died. Nothing like it had been seen in Japan since World War II. And the death toll was to mount further. Outside the fire-torn areas, many lay buried in rubble.
They're looking for the old guy's wife. The guy in the blue is their son. His mom's in there somewhere. They can't find her.
Across the city, rescue work was carried out by neighbors and desperate relatives. The man is calling for his mother, buried somewhere below. NHK reporters were shocked by what they found.
I'm in the middle of this area. Please look at this. The second floor of this house just fell down. Look at it closely. The first floor collapsed, and the second floor fell down, and everything fell out.
Ugh, what a mess.
2 people were rescued, and 1 person died.
Wood-framed buildings had simply been shaken.
Imagine trying to find somebody in that.
The contents either killing or severely injuring the occupants.
So now please, look at this over here.
On the roofs of these traditional style houses were heavy tiles, protection against typhoons, but lethal in earthquakes. Supported only by timber posts, they were responsible for many deaths.
As you can see, the tiles were broken, and this piece of wall, it's made of straw and mud. So many old houses like this were damaged or collapsed completely. The tiles broke into pieces, and even the symbol of the house fell.
On every roof was a heavy stone ornament, symbol of life.
That says over 4,000 dead.
The final toll was horrific. More than 5,400 people died.
This is a cemetery.
The Northridge, where the death toll.
Look how crowded the cemetery is.
Ironically, seismologists need earthquakes in order to work out what is happening underground. Now, they understand what caused both of these earthquakes.
Did you catch that?
And why.
Earthquakes let you know where there's going to be more earthquakes. We need to find the faults.
One or 2 known faults run under Kobe.
The way you find faults is using earthquakes.
Fault lines in the Kobe area. The whole of Japan is crisscrossed by fault lines, large and small.
Look at all those faults.
Japan sits on the junction of no less than 4 tectonic plates, segments of the Earth's crust. The Pacific Plate and the Philippine Sea Plate are in collision with the Eurasian Plate and the North American.
You live on the North American plate.
Each plate is forced to slide under or over the others.
4 plates all trying to be at the same place at the same time. Look at that.
All this conflicting motion is responsible for the sudden movements on faults near plate boundaries.
See that arrow going down? That's a subduction zone.
Northern Japan is sitting on a corner of the North American Plate. This huge plate spans much of the Arctic and most of North America. A sliver of California is cut off by the plate boundary.
See the knuckle where it can't slide by?
Mexico is on the edge of the plate, while the coast of Southern California is on the other side.
Los Angeles is sitting on the Pacific Ocean plate, and it's being moved to the northwest compared to North America at a rate of just under a couple of inches a year. It's about the same rate that your fingernails grow. And in 5 or 10 million years, we're going to have Los Angeles as a suburb of San Francisco, or San Francisco as a suburb of Los Angeles, depending on your point of view. And in 50 million years or so, we'll be actually heading up into Alaska, giving up on our palm trees.
See, it's trying to slide by, but it can't.
There's a bend near Los Angeles where the plates grind together.
See the knuckles?
As in Japan, this produces cracks in the plates, just like broken crockery. Some of the fragments rise up over others, and this gradually builds mountains, both in Japan and in California.
That's San Andreas Fault right there. That straight line. That's the actual fault.
Was the earthquake at Northridge. As with Kobe, the seismologists had trouble locating the epicenter. Communication with some of the seismic stations was lost, and others went off scale.
Notice?
The traces had square tops.
The tops that are flat on top? There's something wrong.
It took nearly an hour to pinpoint the epicenter on Northridge.
The waves from it came up and hit a lot of our stations.
Okay, listen to what she says.
And it fit the pattern for microwave.
She either says 10 minutes or 2 minutes.
The ground is moving in so many places all at once. This can't be real. This must be a glitch in the microwave system, and threw it out. So when we got in there, instead of coming up with a location like we would hope to do, we often get a location within 2 minutes. Instead, we had the system saying, oh, nothing's happened. Well, yes, there was a bit of noise in the system, nothing's happened, and we had to retrieve it.
When they went to retrieve the seismic record from the ruins of Kobe, they found they had similar problems. The seismometers had successfully survived the earthquake, but there was no communications link back to base.
Look at the graph.
The traces showed that once again, the instruments had gone off scale.
Those should not be flat on the top.
Square tops, as in Northridge.
Something's wrong.
Seismometers were just not sophisticated enough to cope with a massive earthquake.
That's a seismograph.
As many as 20 or 30 small and medium-sized earthquakes occur every day in Japan and in California. Much time and effort has been spent on searching seismic records for patterns which might help predict the big ones. No patterns have appeared. Many methods have been tried.
Old
By chance,
technology here. This is an old video.
has yet been successfully predicted. Kobe and Northridge both lie in earthquake-prone regions, but neither is on a major fault.
Both earthquakes were rather unlikely earthquakes, which is an important point to stress, that they're not the earthquakes that most people would have said would affect either Los Angeles or Kobe. So it's important that we recognize that earthquakes will occur in unexpected places and at unexpected times.
See the crack in the ground?
Earthquakes had several unexpected elements. On Awaji Island, south of the Kobe epicenter,
You can see the fault right there.
and the surface of the ground could clearly be seen. But in Kobe itself, in among the rubble, no fractures in the ground were apparent. The fault line was invisible. Without an array of seismometers, it is hard to tell how the ground has actually moved.
All right, this guy is really smart.
Oklahoma University
This is one of my favorite parts.
had a bright idea to get around the lack of information.
Watch this. Inside of those bags,
Security cameras in convenience stores would have recorded the movements of items of furniture.
he's got videotapes
Anything on wheels.
from security cameras.
This is a film from a
Pay attention to this. It's very important.
inside of
Pay attention. Okay,
This person noticed a vertical shape from the earthquake.
watch. As soon as he hands back the change, they just felt something.
Movements in other directions.
And now the big earthquake waves show up.
Reflect the movement of the fault.
Look at the mess. Watch.
Then notice something
Right then, they just felt something.
That's the first small shock wave. Then this trolley on wheels tries to stay where it is, while all else around it.
Look at the how much stuff spills. Look at the mess this place is.
Shows the direction of ground motion.
Okay, this is a different store.
Professor applied the
Different
analysis
store.
to moving objects in other stores. Then he studied the contents of the NHK studio.
Okay, here's Mr. Futon
The
again.
person sleeping. He wakes up when the vertical movement hits.
Watch all the stuff on wheels move.
Movement of this chair.
And that cabinet is on wheels.
Then there's the cabinet, which moves out into the room. I thought they might show the way the fault had moved.
So, watch his bright idea. This is really smart.
Revealed the position of the fault. It was not the same.
Every place there's arrows, that's where he got a videotape from a security camera.
Another similarity.
That's how they found out where the fault was, from the security cameras.
The morning of the earthquake, we went up in a helicopter to try to find surface rupture, which helps us greatly in understanding which fault broke in the earthquake, which we were trying to determine the day of the earthquake.
They spent several hours flying around the epicentral area looking for the surface rupture.
They can't find any cracks.
They couldn't find it.
It's one of those unfortunate instances where we had to have an earthquake to find out where the fault that broke in the earthquake was. We didn't know that the fault that broke in the Northridge earthquake existed before the earthquake.
Later, computer analysis from seismometers showed how the crack in the rock had migrated upward. Then it just faded out before it got to the surface, making it invisible to geologists.
That's why there's no crack on the ground surface.
They have recently calculated that there are blind faults like this all over the Los Angeles basin. Guessing which one will produce the next earthquake is virtually impossible.
Oh my gosh.
Here's an aftershock. Notice the broken glass?
Certainty about a big earthquake, as the smaller quakes will follow.
Okay, come on back, come on back.
Here's a hill that buried a bunch of cars.
Scientists swarmed over the area around North.
See the dust?
Recorded the inevitable aftershocks.
The dust is showing you where the fault is.
Clustered around the original epicenter, they could be plotted in 3 dimensions. This is the San Fernando Valley in there, and this is the main part of Los Angeles.
Okay, we're about ready to finish.
Mountains in between.
Now,
And the earthquake occurred in this area. We'll be able to see below the surface.
I'm gonna hit pause for a second. Remember when I did this bunch of like 80 dots on a graph and to show you where a plate was? He's gonna do something similar here. I'm gonna hit play again. He's gonna rotate this computer view. Look at all the little red dots. Each one of them is a separate detected earthquake. Okay, now watch. See all those little red dots?
And you can see.
It looks like it's random, doesn't it?
Here and actually
Wait till he turns it.
From the bottom to the top. We'll rotate this around by 90 degrees.
Do you see something happening?
Look at the fault plane from side on, and you will be able to see the earthquakes lining up on the fault.
There's the fault.
It started at the bottom, ruptured up to the top. This area up here to the north is the area that received the very strongest shaking. And Los Angeles, in this case, is off in this direction, so it did not receive the strongest shaking. The strongest shaking occurred in the mountains.
Up in the hills.
Northern part of the San Fernando
On the
Valley.
ridge.
But the main part of the city over here was spared from the strongest shaking.
All right. Now, I'm already at 26 and a half minutes. I'm going to wrap this up. Okay? So, there's the notes you took. We're going to continue this on some more. Make sure you get all the videos watched that I've assigned. There's a quiz coming up, and you're going to have watched the videos. Some of the answers will be on stuff that I said or that you heard, not that you wrote down.